Hi everyone. We are back online learning on Monday, and for various reasons, I'm away on Tuesday as well, or it might be online learning the way things are going. So I'm going to do a couple of different ones, but today we're going to look at area of simple shapes, moving through measurement again. So I want to take note of just quickly run through, and these are all referred to in your textbook on page 154. So and it's stuff that you've seen before. So I'm not going to go through every single one, but we are going to be using them. A couple of them that I want to take note of. And the key with measurement is to make sure that you relate things together. So I'll give you an example of relating them together. You see a rhombus is half times the product of the diagonals. Well, a kite is not a type of rhombus, but a rhombus is a type of a kite, as in the diagonals bisect and you have two pairs of equal sides that are adjacent to each other. So that's what happens, right? So half times x times y is the formula for both. Now you do get most of these in formula sheets, and we'll go through that. So that's a key one to note, the kind of rhombus and kite being the same formula, because a rhombus is a type of a kite. The other one that's often tricky is when we have a triangle, half times base times height, that's fine, half BH. For this one, tick, that's easy. It's just a right angle triangle. You can see how it's just half of the rectangle there. This one, also easy, tick. The height is very easy to see, but when we get ones like this, these ones are trickier, these third one. And so the idea is that the height is you have to extend the base out, but you're not extending the base, you're just kind of taking the base's direction until you get to a point where you can take a perpendicular height. And so it's that. So it's not this, and it's not this, and it's not this, or anything like that. Although it's not what it is, it's this height here. So just take note of this one, because this often trips people up, and they kind of throw them in there, and the shape is kind of a bit different. So that's to note. Then we have a couple of other ones. The kite I already spoke about. Trapeziums, again, it's the average of the two parallel sides. All right, two parallel sides, you take their average, A plus B, you divide it by 2, and then you multiply that by the height. That's how I remember it. But there's many ways you can form it, but essentially what you're doing is taking the average of the two sides parallel to each other, then multiplying it by the distance between them, which is what we call the height. Pi r squared for circle, and then the last one I just want to focus in on, the sector, which is like a piece of pie. It's A, which is the angle inside, A over 360 degrees times pi r squared. So pi r squared is a full circle. The A over 360 gives you, this part here is the proportion of the circle. Proportion of the circle. So whatever it might be, you've got 90 degrees, obviously it's 90 over 360, that's a quarter, it simplifies to a quarter, but any angle it just works, and you just multiply that. So basically you're saying the proportion of pi r squared. That's what multiplication is, proportion of pi r squared. So if we know these few ones and we can apply them, let's just see what we can see for ourselves. We've got a few, few sort of basic ones that we have. So let's have a look at some examples. It's just a matter of looking at the shapes, applying it, and then of course there's going to be some compound ones, which I'll do some examples of later in a shorter other video. But this one's an interesting one. You've got a parallelogram. Given a parallelogram. And you're told that this is 25, and you're told that this is 5 meters. That's parallel, that's parallel. That's parallel to that, so that makes it a parallelogram. And then the diagram has, let me change that size, the diagram has this. It doesn't give you the height, but it does tell you that the distance here is 3 meters, And we have that. So how do we do it? Well, we need to find the height, right? Which we don't know what that is, question mark. But that is the same as this height, question mark. Which instead of a question mark, let's call it h. You notice that this triangle here, I'm going to redraw it, is a right angle triangle. So we should use Pythagoras' theorem. That's 3, 5. And so this would be h squared is equal to 5 squared minus 3 squared. And that's equal to 25 minus 9, which is equal to 16. So h is equal to 4. So actually the height here is 4. And so therefore, this one, the area is equal to simply the base times the height. These are parallelograms. So it's 25 times 4, which is equal to 100 square meters. Make sure we're doing the correct units. 100 square meters. Just throw in something else. I mean, again, the kite at the rhombus, you literally take half times the product of the diagonals. It's to do with triangles, actually, half times base times height, but you have kind of two heights, if that makes sense. So, yeah, anyway, that's the way it goes. Let's do a trapezium question. Another classic one, and then I'm going to stop and do another video, but there's another classic type of question that throws people. We're very comfortable seeing trapeziums like this, you know, where you've got your nice shape, all right, and you have your distance here, and that's parallel to that, and let's say that's 16 meters, and that's 21 meters, and the distance between them is 15 meters. Well, that is very simple. I'm going to call this 2a. A is equal to half times the sum of the sides, which is 16 plus 21, times the height, which is 15. So we've got 16 plus 21 divided by 2 times 15, and 277.5 square meters. Again, being careful to do that. That's exact. The one we're not so familiar with is this type. Again, they like to throw them in lots of questions, so you might as well go and see them from the start. This also is a trapezium, but we're used to seeing it like this. We're not used to seeing them like this. And it's got a right angle there, and let's say you've got 14 centimeters, 18 centimeters, 12 centimeters. What we have is actually, even though it's not marked, is that this side is parallel to this side. How do I know that? Because these are right angles. That's given to me. So these are my top and my bottom as we would normally see it on one like this, but the parallel sides, my A and my B. Another strategy is to actually write in another color what the different things are, so you don't get confused. And so the area of this figure would be A equals half. Another way you can write it is 14 plus 18. The two parallel sides added together, divided by 2 over 2, times the height, or the distance between them. All right, so 14 plus, that's 32, divided by 2, 16, times 12, don't know how you 16 times 7 stars, mine not so good. We figure it out, 192 square centimeters. All right, so that is one to note. There's a couple of key things to note. I would note this shape, just in terms of a future reference, because it is a trapezium, but not as familiar as what we usually see. And so it's a case of being able to think about it and what shape it is without being able to do that. Okay, I'll upload this one, but let's have a look at some other things in the next video.